We're talking about the natural base E and modeling continuously compounded interest. So we have example 5 here. We have a word problem. Ms. Graham wants to have $500,000 in a retirement account when she retires in 18 years. How much does she need to invest now if her account earns a fixed annual interest rate of 6.79% compounded continuously? So we're still going to use, because it's compounded continuously, the PERT equation. And so we have to be able to substitute those values in to figure out what we're going to do. So in this case, we're given our goal. Our goal we're trying to get to 500,000. The years, we are told that the years it's 18 years. We don't know what the principal is. We're trying to figure that one out. And the annual interest rate, we are told, is 6.79%. But we know that it has to be expressed as a decimal. So when we substitute that into our equation, we're going to go 0.0679. And so we're going to use all those things, substitute them in, and then we're going to be able to calculate what our p-value is. So PERT, A is equal to PERT, and we're going to substitute our values in. So we have 500,000. We don't know what P is. We got to solve for P. E is a constant, even though it's just like pi, representing it with the letter E. R is 0.0679. And T is 18 years. Now, this looks like a lot, but really, all this information right here, that is a constant. That's not going to change. So we only have one variable that we have to solve for. So in this case, when we're trying to get P by itself, P times E, right? P multiplied by E. So all we have to do is to get P by itself, or the principal by itself, is we're just going to divide by E raised to the 0.0679 times 18. And I have to divide the other side by that as well. 0.0679, 18. All right. I can substitute all this stuff into my calculator and get a value. So when we get done, we're going to know that P is going to be equal to something. So I have my calculator here, and we're just going to do it the same way that we've always done. So we'll start with the 500,000, just typing that in. Then we're going to divide by, and remember, we want to use that E button, which is right above the natural log. So second E, and all I'm going to use is I'm going to use my parentheses, and I'm going to type it in exactly as it is there, 0.0679 divided by, or excuse me, that's multiplied by 18. That's exactly how it is on my paper. And when we get done, we have to start with $147,290 and 68.7 cents. So I'll write that down. So this is what we have to start with: 147,290, and then we can round that. And if we have this amount of money in 18 years from now invested at 6.79%, we will hit the goal of $500,000.